So what I'm going to do is I'm going to talk a bit about deploying Python web apps to OpenShift. I'm just going to show some of the basics of how you can use the source-to-image strategy in particular to very quickly get a Python web app in. And I've been playing around with that, and I've learned various things from that, and the current support in OpenShift sort of it's a thing that's still evolving to be improved. And what I've been doing is working on my own what we call source-to-image builder images for Python. So I'm going to go into some of the things I've done with that and some of my own ideas of where I think OpenShift itself should go in that area and how it can be improved. So down further, if you had all got this up and it's gone down.
Hey Graham, can you increase the font a little bit?
Oh, that's right, you're up the back, aren't you?
And Graham is also a little modest. He created a modest WSGI server for Python, so you may have heard of that.
That's not the way to explain it. The way to explain it is I killed this thing called mod Python, which sort of deserved to go away. People should not be using it. It's got big security issues in it which no one really understands and appreciates. Okay. So deploying applications to OpenShift. There are three primary ways that one can deploy an application to OpenShift. The first way is that you already have a Docker image already created from somewhere. You could have created it on your own laptop and you've loaded it up to a registry such as Docker Hub. So you're able to tell OpenShift that I want to pull that image down and it will just run it up. Like any other Docker image. If you're talking about OpenShift products from Red Hat, then there's certain restrictions that you may find. We don't like people running as root for various reasons. So not every single Docker image you find up on Docker Hub will necessarily work. As long as people are set up so it can run as a non-root user, you should be okay. The second way is that rather than you build the Docker image yourself, you can effectively point OpenShift at a Git repository which has the code required to build a Docker image, so it's going to have that Docker file in there. And you can get OpenShift to do it on your behalf. And that saves you having to push images around, which can be really annoying, or avoids using automated builds on Docker Hub, which drive me absolutely nuts because they don't work half the time. And the third way, which is one can do it, is that rather than build a Docker image at all yourself, you can what's called source-to-image, which we'll call source strategy. And the idea with this is that someone will build a base image for Docker, which has all the bits and pieces in it which are required for programming in the particular language you're using. And today we'll be talking about Python. And what happens is that OpenShift you point it at your Git repository again, but in this case, what's in your Git repository is just your web application code. And OpenShift, when it runs up the builder, will pull that Git repository down, essentially incorporates it. It's going to create a new Docker image for you, and that's so you don't have to know about how to do Docker images yourself. We'll pour that into a new image which is built from that base image, the source-to-image base image, and we'll look in that source repository, and in the case of Python, we'll install packages and so on, and create your final image for you. And so what we're going to do is we're going to go through the source-to-image one in this. I'm not going to do the other ones, so mainly interested in the Python source-to-image. Now I've got various web applications up that I'm going to be using up on my Git repository. I'm going to focus on a Django web application. And I've created that by essentially just creating a fresh repository. I've done a Django start project and created basically a Hello World app. It's not much to it. I've not done anything special for it for OpenShift. So we're just going to go through here. Now, most of the notes here talk about things in terms of doing from the command line. But I'm actually going to jump first into the web UI and quickly show you how it will be done there. So if I just copy the URL for my app, oh, I need to create a project first. So if you are following through, you need to create a, I'm using user 00, so if you do have the existing account, I'm sorry we didn't talk about giving anyone else any user IDs. Create. So these are all the source to image builders that exist in the OpenShift installation we're using, and there may be some quick start apps in there as well. So what I'm going to do is going to search for the Python one. I'm going to select a particular version of Python here, Python 2.7. I'm going to call this Django Hello World and give it my Git URL. There are some more other options you can go here and set, and one in particular I'll point out is this thing down here, which is the routing. There's actually a slight little difference between when you do things through the UI whereas you do it on the command line. If you do it through the UI, it by default will expose your web app automatically to the public internet, whereas if you do it from the command line, that's a separate step. Used to confuse me no end, I would keep forgetting that. So we're going to create this, and that's going to go off and start deploying it. So what that's doing now is that's pulling down that Git repository, creating a new Docker in which incorporates that source code, and that's what we call the assemble phase. It's controlled by this assemble script that's part of the source to image builder. It's the thing that's going to go look at the requirements.txt file in your Git repository, which has a list of all the Python modules you need. It's going to go and install them. In the case of Django, it's going to realise you've got a Django app by looking at what the code is and run python manage.py collect static, which creates all those static files which you need in a Django app for the admin interface and any other things you're doing. And that's going to take a little while. So we can look at what it's actually doing. We hope it's doing something. So the first time you actually, one thing is, which is really annoying for demos, is that the first time you use an image in a cluster, it obviously has to get it down from Docker Hub. That shouldn't be doing that because I've done it in a separate project. So maybe it's happening because I'm in a separate account. I did it in a different account last time. Anyway, while that's going on, let's instead do it on the command line. So in the case of the command line, I'm already logged in, so I've got all these different projects here. I need to be in the correct project because I'm most likely in the wrong one at the moment because I just created it. And what we can actually do here first off is even look at what that other one is doing. So it's still waiting for the build. So because I did this in a different account to what I was testing on it earlier, it looks like it's having to pull down that image from somewhere first. Actually, it's a built-in image, so it shouldn't. So hopefully there's not a problem going on here. So this time I'm going to create with the command line. Now, interesting distinction here. When I did it from the UI, I specifically chose that I wanted to use Python in a particular version. And here, when I've done an OC new app, I have just given it the Git repository and nothing else. I haven't told it it's a Python app. And what's happening here is the OC new app has some smarts in it that when it gets down that Git repository, it will actually look inside of a Git repository and try and determine what language you are using. So in the case of Python, it's going to look for whether you have a requirements.txt file, which is going to be the list of modules to be installed by pip, or it has a setup.py file, which is an older way that used to be used back before pip became popular as a way of installing a package, application as an actual package itself, and you can have your dependencies listed in there. So in this case, it's sort of knows because I've got a requirements.txt file in there which is listing Django that it was Python, and it's going to go and fire off Python for me.
How it will find out if it is Python 2 or Python 3?
Okay, as I was about to mention. So OpenShift installation exists now, supports Python 2.7, 3.3 and 3.4. No 3.5 yet. And the free4 image essentially is tagged as being the latest. So if you go and do a deploy, it's going to just use whatever is the latest one. And so in this case, it's going to be using Python free4. The alternative is if you know that you want a particular version, is it Python 2.7 or?
Might be a dash.
You reckon it's a dash? Yeah, I got it in my notes down here. So Python language protection. Yeah, no, Python 2.7. So yeah, so that's why you can actually select a particular version, and we're going to actually use that ability. So essentially, what we're saying here is here's our source code, and this is the particular builder that we want to use. In this case, it's Python 2.7, and we'll use that later when I start talking about different builders and replacing the default one. So let's see how this thing is going. Okay, so our original one's up. Oh no, that's interesting. Our original one is still going for some reason. But the one we just created is fine. So let's look at the one we created. And here is what I meant. Is that you look at the top one here, it's got this is going to be the actual URL. And it's running very slow. Because we had the previous workshop running, maybe someone's been doing some interesting things with scaling up a lot of instances of an app and it's all running a bit slow. We'll see how we go. So that one had a URL, exposed URL already. This one didn't. So because we did it from the command line, we're going to need to expose it. And that's done using this OC expose. So expose the service. And let's see if we can get to this one. Yes. And for Django app, if we go to admin, you'll see that the admin works. We have style sheets working. So our static files are also being hosted automatically. That one must just be broken, which is a pity. Now, what I want to do next, I want to talk a bit about application and deployment workflow, because it's all well and good that you can get an app up there, but what does that mean to the way that you're going to work day to day? Now, it doesn't change it too much in perspective relative to how you're used to just doing database development. With Django, you got the development server, which is built in, so nothing changes there. You're going to work on this thing. You still make your changes, use the Django development server, use the fact that we can do code reloading to automatically pick up changes if need be, and nothing's going to change there. But we still need to get our changes up and deployed publicly. So publishing your code changes. We created this originally against a Git repo, so obviously going to check that out. So the workflow is basically do your local development with Python Django development server. When you're happy, commit your changes and push them up to the Git repository. Now, if you're familiar with OpenShift v2, I find that the way how v2 worked a little bit confusing actually, because you could just create your Git repository locally on your disk. Well, actually, OpenShift itself effectively was running a Git repository for you, Git server, like a GitHub inside of OpenShift. And so when you created your app, there's a few things that could happen, but generally you created your app in OpenShift and then checked that out and then started making modifications in that. Or alternatively, you could do that initially, but you might already have an existing app, so you got all this funny messing around with changing it to then push to OpenShift and do a force push initially to update it. But anyway, the thing is that to do deployments previously in v2, you would do all your code changes, commit it, and you would push them direct into OpenShift. And that would cause your web app changes to then actually be deployed. In OpenShift v3, you've told it where your GitHub repository exists or whichever other public or private repository it's linked to. And you're, instead of pushing your changes direct to OpenShift, you're just pushing it to your normal repository. At this point, there is no linkage between that repository and OpenShift. That means that if you do want to trigger a new deployment based on code changes, then you have to trigger a build. And that can be done on the command line using OC start build, or you can do it through the UI. And I'm really hesitant to trigger any if this is going to... well, let's say this has failed, okay? And I'm going to assume it's a timeout.
Can you try OC describe?
Well, I'm pretty sure it's going to be a timeout, yeah. This is the problem we've been seeing occasionally on our own cluster. We hadn't seen it on this one we're using for the demos. But let's use that fact. We can go in here and go build. So if you've made a change, I can go over here and go start build. And that's going to pull down the latest version of the source code from the Git repository. Build you a new image and deploy it. And that all happening. So that's a manual process. But what we can do is that... I'll skip that bit. We can use what's called webhooks, and Grant talked about this a little bit in the previous workshop, so I wasn't going to go into depth with it. But the idea here is that you can get what's called a webhook URL from the configuration in OpenShift for your project or your application, and you can set up GitHub with that webhook. And what that means now is that every time that you commit to the Git repository up on GitHub, it will automatically notify OpenShift that there's a new version of code there, and that will automatically trigger a build. So you get the same effect as what you could do in OpenShift v2 of when you did a push, does a change. It's just going on a different way. It's going via where your Git repository is this time rather than direct into OpenShift. Let's see how our build's going. Yeah, this time it works. So we've got two deployed apps. Yeah, we're going for time. Now, what about if you don't like the fact that to get this now deployed, I'm having to always commit my work and push it up to GitHub? If you're doing lots of little changes, like you've done all your work presumably with Django Development Server, but you get situations where your deployment environment is going to be different to your local development environment. And so sometimes you can have a problem where you can't replicate an issue you're having in your local development environment. You can only see it occurring in your actual deployment environment. And in that sort of situation, what is a pain is having to make a little change on your repository, do a commit, and wait for the build to occur, and then find, well, that didn't quite work. I'll go and make another change, do another commit, and when you do that, you end up with all these little commit history in your Git repository, and some people don't like that sort of little trail of all those commits. You could do rebasing and squashing and all this sort of nonsense, and I personally don't like that. So the alternative of what you can do is what's called binary. We make use of the fact we've got a binary build. So you've got your application already set up, and when we did that start build previously, it's going to cause OpenShift to go back to your Git repository. And what we're going to do this time is circumvent that process. And we've got this command here, OC start build. We're going to build our particular thing again. We're going to say, but take the source code from our current directory on our local box instead of from Git. So let's, where's our, which one will we use this one? So I've got my hello world. So I should make that change. Now, I have not committed this, and I'm going to, I shouldn't cut and paste it, should I? Okay, so this time what's happening is rather than getting the source code repository, source from the remote Git repository, it's bundling up the directory in which I've run this, and it's going to push that into OpenShift, and this time the build is coming from there. So let's see if we can see how long this one's going to take. So this you can see where the build's happening. Let's just dump it over the UI, it's probably just easier to watch over there. So that's already built. It's spun up that new one. Just a warning, the default at the moment is this is using Django Development Server. And I don't know what it is about the Django development server, but it doesn't respond to sig term properly, and it's taking 30 seconds to shut down. That's why we're seeing here. But our app's already running. That should have been taken out of the routing. So we should now be able to go over here, and there's that change. So I never put that up to the Git repository. So that's one way that one can do it. And let's try another way. Now, that doing it from the current directory only affects that one current build. If we were to trigger another build, it'll go back to using the Git repository. It's not a permanent linkage. So if you're happy you've done the right thing, you can go commit that, push up, start a new build, and it'll go to the Git repository. Next thing we could do is live save source code changes. So what we're going to do this time is you can actually get into the running container. Now, if you're familiar with, so for example, Heroku, there was an ability with Heroku to get access into a dyno, but it was a special dyno that was a run up just for your shell access. It wasn't the one where your web app was running, so you couldn't do live code changes. In OpenShift, you can actually get the information about which particular pods are running your app. And in this case, we've only got one. If you have more than one, this gets a bit difficult. We've got one. We can actually get inside of that running container and make code changes. So here's our running app down here. So I'm inside my container, and for some reason I always have to set terminal. So there's my modified one. All I use is capitals there. And there's my change. Now that has worked because it is using the Django development server inside of the container as the default. That's one of the things I'm not necessarily wholly happy with the default builder, because it's using Django development server. If you do Django, that is not a production grade server. You should never use it for various reasons. It's obviously not going to be performant. It's a single process with a single thread. And yes, with OpenShift you could scale up and create more instances with one process and get currency that way, but not a good situation. Now, there's yet another way we've got of working more with this. And Grant touched on this in the previous workshop. So we can do a build which is triggered from our current directory. We can get into the pod and do stuff. The other option is this in OpenShift, this OCParsec. It allows you to actually make all your changes locally on your box and essentially just rsync that changed code directly into the running container. So let's get this one to go. So what are we on? We're still on capitals. Get out of here. What letters will we use this time? Yeah, Zs. So, get pods. So I'm going to rsync this subdirectory which has my app in it. I need to specify the pod. Now, you do need to know where in the I'm bound to get that wrong, so let's just recheck it. Opt at root source hello world. I think I got it right.
How do you know which pod to pick?
You need to replace the apt with T with a P. Opt/apt minus root. Go to the left.
EPP.
More left, more left, more left. Stop. And
Oh,
replace the
okay.
T with a P, yeah.
And there, okay. So let's download up that directory, push it up there. Because it's rsync, our images have rsync.
There was a question on how do you know which pod to use.
Yeah. Oh, okay. So in this case, I've done an OC get Can you see that right down the bottom? I'll do it again. There are different types of pods. There's the ones which actually have your running app, and you'll see these other ones which are the build pods, and you'll see ones that pop up with deploy. So it's a case of just you sort of understand this, learn it over time which is the one, but we've got that one pod there of that. I think there's other ways of doing it. OC describe. I'm doing it from memory here now, so I'll probably get this wrong. I hate it when that happens. Is it service or application control? Anyway, there's other way of doing it, but yeah, I'm doing it that way, so I'm selecting it from there. Now, someone said that, yes, that failed, or appeared to fail. I've got the wrong one, have I? Uproot?
It's only permissions.
I must be giving it the wrong directory then. Let me just cut and paste that bit. Okay, interesting.
Should you read the slash before the hello word, like a root?
So, Graham, you have two pods in a running state. The first one, the 32C47 hash, and then the one on the bottom. What's the difference between those two?
That was the one I created with the web app earlier.
Uh,
That's not the one I'm using now. This is one thing about doing rsyncs that is important. Our builders are set up for this. One, you need an rsync command in there, but all the permissions have to be set up in a way that when you do make changes in the pod, you can actually do them. Our ones are set up to do that. If you take an arbitrary Docker image off Docker Hub and try and do this, it may not work because the permissions may be set up as root or something, but it's running as a non-root user, so you might be able to do it. I can't see exactly what the problem is there.
I think it works. It's just a permission on top.
Yeah, okay. Yeah, you're right. I've done it once before, and the first time we saw all the files changed. Yes, this is only on the directory, and I need to talk to someone about why this occurs, but I have noticed this. It can't update permissions on just the directory. All the files get updated, but you get this strange message. Now, Grant gave a interesting example in the last talk. What Grant does is actually sets up his editor so that whenever he saves a file locally, he will automatically go and update all these things. And one of the questions was, how do you find the pod? And actually, here's the way that I came up with. I've got this little script here. So you can actually use the OC get pods command and use what's called a selector. So I'm going to select just the pods which are for my particular application. And I'm going to ask just for the name of the pod. And now I'm on the basis that I'm only going to have one single pod. So I'll get my pod name like that. And then I'm going to feed that into the rsync command. So you could, if you're in an editor environment, set your editor up so you could run this little script and just give it the name of the app, where you're going to do it from, however the editor works that out, and what your destination is. And that way you could trigger it off doing it off the editor. Does anyone tell me when this is meant to finish? We've got 10 more minutes?
Yes.
So that was one of the key things I wanted to talk about in this one, was the different ways you could work with it. Because people look at look at OpenShift or OCParsec like that, and they think they have to change their workflow around totally and just do everything in a much strange way. There are some things which are different, but the basic things still work, like the development server and commuting and so on. You're still doing all that, but you can try and set up those workflows through webhooks to try and automate things, and you do have these ways of doing live changes still. You aren't precluded from doing that, which a lot of people think, oh, well, I can't make live changes anymore, but you can. Now a bit more about the default Python builder, and we'll finish up there after that. So it's doing a lot of automatic things here, and like magic is good when it works because you don't have to think too hard. You can just get your Git repository. It'll hopefully just deploy it, and you don't have to worry about it. Now, what the default builder currently does is it goes through a strategy, a few different steps, and try and work out how it's going to deploy things. And the first thing it will look for is whether your repository has an app.py file. And in that case, it presumes that you are going to supply the whole Python web application. So in this case, you might, for example, be using Tornado, async server or something other. So you actually have your Python app.py, it's importing the Tornado module files, setting up all your handlers, and basically running it. Or you could, even though you're using Tornado, still be using WSGI app, but just using its WSGI container. The next thing it will do is if you've got Gunicorn installed, so if you in your requirements.txt file have installed Gunicorn as part of your packages, it will go through and look and see whether you have a WSGI.py file somewhere in your repository, which is going to be containing the WSGI application entry point. And if it finds that, it'll run up Gunicorn against you. So you haven't had to define how the server is actually started up. Finally, if you have a manage.py file, it assumes you're running Django, and it will just use Django run server.
You don't have to define, but you can define how the service is going to be run?
Yeah, that's one of my issues with the current default builder at the moment. That's a bit difficult to try to override everything. Your only options are basically Gunicorn or an app.py file. And that means if you want to run uWSGI, for example, you would have to have an app.py file which does an OSXL of uWSGI binary, which is a bit strange. The other thing is it does push you towards Gunicorn, which me personally, okay, I'm very biased because I wrote my WSGI, but I have very good reasons for thinking that Gunicorn is not necessarily a good choice for containerized environments. It has only single request worker per process, which means if you need to scale up, you have to create more processes, which means more memory. And in a PaaS environment, yes, you've got to worry about issues about Python global interpreter lock, but you've also got memory constraints. And so having to scale through using multiple processes is not necessarily good. If you've got an IO-bound app, it's often better to scale using threading, because the GIL is not a problem. So that's one of the reasons I'm not too keen on the Gunicorn. So I'll flick all past this. So alternative Python S2I builders. So OpenShift does provide a default, but you don't have to use it. You could write your own S2I builder if you wanted this style of environment. You might just say, oh, okay, I don't want to do anything to do with source image and just build your whole Docker image from scratch if you wanted it. And most people out there, that's what they're currently doing. But source to image is good because, especially if you're coming from a DevOps background, because you can say to the developer, you just need to worry about writing your app. Here's the S2I builder you can use. Now, it may be default, or they may have developed their own one. And that allows them to incorporate in that builder image all the things that they as ops people want to see in there. That may be, it might be a particular Python WSGI server that they want used. They might want monitoring, such as New Relic embedded in there to do monitoring. They can set all that up automatically, so you as a developer don't care. Now, obviously, I'm keen on mod WSGI. So I've been playing around with my own Docker images for quite some time. I only started with Red Hat middle of last year. Last year. And I was doing it before that, and since obviously I got into Red Hat, I've taken my existing image, I've sourced to image and enabled it, and I've been playing with it. And my latest incarnation, I'm just going to show you where I'm at with that. Okay, so this is where I'm going with my image, and I sort of same issues you're mentioning is what if you want to take over control, because I want to be able to do that. So I provide a lot more options in my image And the idea is that I've done this, and I'm talking to the people, other people in Red Hat who are developing the default, and I'm trying to get them to do changes to incorporate some of these images so we can improve on it. So the default one's better, but also you still have this option externally. And I'm sort of hoping that with my one, because I want to do things that Red Hat would never want to do in theirs. I like use source tarballs for Python, so you can have the latest versus packaged, for example. I'm hoping to get community interest in my image and perhaps get web community cooperating to have a web community managed one. And that way we can come up with a best of breed one. And that'll be an option.
In OpenShift, do you have the possibility to choose a default? Do you have more defaults? Could you create profiles, for example, in OpenShift, and you can choose what defaults you would like to have for Python, for example?
Okay, so the only default that really exists is that if you use OC new app on the command line and don't tell it to use the Python image, it'll do that language detection. In that case, it then, once it sees it's Python, will look for what we call the image stream, which is essentially a Docker image, called Python. Now, if you wanted to use that language detection, but didn't want to use the default, then you can create a image stream local to your project, which maps Python to mine, for example. And that way you could override it. Hopefully that works. I found an issue with it in the last version. I'm not sure. I haven't tested it in the one we've just released as to whether that overriding does work. But that's the idea. So, but besides the language detection, you're going to generally specify the builder you want to use anyway.
It would be nice if in OpenShift you have the possibility to choose, when you customize a project, choose maybe some defaults.
Yeah, and the only way is to override the Python image stream. That's probably the only way I can see to do it. So, in my image, if you want to use WSGI, or just totally control, you want to run any command line WSGI server, I allow you to provide an app.sh, so shell script, and you can run whatever you want, however you want it. It looks for an app.py. It'll look for a paste.ini file if you're using paste or with pylons or pyramid, which you use that sort of thing. And it will just go and automatically run up. So I'm using ModWSGI Express there to do that. That's sort of, if you're not familiar with it, it's a bit different to straight ModWSGI. So ModWSGI Express, a little bit of confusion over it. ModWSGI Express is, to install that, you basically go pip install ModWSGI. And it's not this totally new WSGI server I've written. It's still ModWSGI. But what ModWSGI Express does is just generate all the Apache configuration for you on the fly. So you don't have to do it. So you're relying on the fact that I know how to set up Apache, and it's probably going to do it better than what the default config is that you'll find on your operating system, which is generally set up for PHP. So nothing special about it, it just saves you a lot of effort. I look for whisky.py file, and if you come from OpenShift 2, the default builder sort of doesn't have a sort of upgrade path. My one, I've been fiddling around with it. It will sort of do some of the things that OpenShift v2 did, with knowing that if you've got a WSGI/static directory, it's going to be static files. I'll mount that as /static. Or if you've got a WSGI application file, it's actually a whisky.py file equivalent. So I'm trying to do that equivalent so we can have an upgrade path. Setup.py file again, look for, and a manage.py. So manage.py is Django, but the important thing is I'm not using Django Development Server here at all. It will actually query using manage.py to find out what the configuration of your Django app is, and automatically run it up under ModWSGI Express. So you're going to have a production grade server in all of this. How are we going for time? 1 minute. So very quickly then, to get to that question of taking control. So by default it works in an auto mode. So I'll look for shell app.sh, app.py, paste or Django. That works in an auto mode. I'll generate all its data. But yes, if you want to take control, you can instead set in a particular file, I want to use Unicorn, or I want to use ModWSGI, or Waitress, or uWSGI. And in that particular case, when you do that and you're taking control, then it's up to you to provide all the configuration. And I've got various examples there, and yeah, I'll leave it at that. If you go to the page, there's various examples, you can dig around there. There's a particular file which is set called warp drive server type. Do I see it there mentioned? No. Okay, so there is this warp drive server type, so that's where you can specify what it is. If you need to override and circumvent the algorithm of what it chooses. And there's a server args file, so what it will do is that you've said that you want to use Gunicorn, but you don't have to run Gunicorn. I'll run Gunicorn for you, and I will supply the minimum options that are needed to Gunicorn or uWSGI or Waitress to have it work properly inside of the Docker container. So it'll set up logging to ensure it goes to stood out. It'll bind on the correct port for listening to connections. All those sorts of things the minimum will be done for you. But after that, you then have to provide the options you need, telling it where your app is and all that sort of thing. So we'll leave it at that. You can dig around here on the Git repo. There's lots of other things that my builder can do, which the others can't do, which I think is more useful, being able to configure it for environment variables and change various things like that. Our ModWSGI Express still has an auto-relating mode, so you can enable that if you still want to do live code editing. Any questions? I talked too fast, didn't I? Sorry. I had that issue when I came over here. It seems my Australian accent does cause confusion for some people of being able to understand it.
Maybe a stupid one. The static files are also handled through this WSGI.
In my case with ModWSGI Express, because it's actually is starting Apache, and Apache can handle static files very well, then yes. Yeah. So what will happen is that you can point at a directory of static files. The Apache part will do that, and your Python web will be handled by ModWSGI. And if you're familiar with ModWSGI, there's two modes. There's an embedded mode and a daemon mode. Daemon mode is always the one you should use, even though it's not the default. But ModWSGI Express will always use daemon mode for you.
Thanks, Graham.
So that's that link up there if you want to quickly write it down.
So just on it. So what does in that process? You start another code, or you said you're starting Apache, right? How was that happen? Because I'm like, I've never done OpenShift. I was plus you with MacOS. So and I'm writing, like just code. When I use your warp drive, it means like that I'm somehow doing the for the environment.
Are you leaving?
Yeah,
So
well, I might
Apache is in place, isn't it?
and then
As is ModWSGI.
I have another
That's in your
presentation, another role.
You?
Please stay
There's
here.
source to image docs so it's all installed all there ready for you. So I'm going to run ModWSGI Express, and when you click the options, you just go, here's the static files, here's my WSGI application, and it generates dynamically all the configurations.
Not bad too. A little bit tired, but it's okay.
So you don't have to fiddle around.
That's always
with
the case
bringing
when
Apache or Unix or
How long are you going to stay here?
Oh, actually, I came on Monday because we were having the time.
Yes. Yeah.
And actually, it was on Thursday, the weekend before.
and running.
So it's 2 weeks straight.
Yeah, well, 10 days with that.
Oh God! And when are you leaving?
Now that's just doing all the commands to restore.
Sunday night,
Everything.
except my weekend because my flight is on Friday every
The
morning.
program that drives
We
it,
go
once
to
you
Vienna,
assemble it,
Oh, from Vienna.
commit that Docker
I live now in Malaga.
and then you've got Docker
South
image run out.
Yeah, Malaga. I've been there one day.
Yeah,
but,
so it's just a part of the workflow.
I went there and then we went to Nepal,
America, yes.
and then to Canada. So, yeah, nice places. Don't tell me now. I want to go to it.
It's your
You are always welcome.
application.
Oh yeah.
Oh, they're all
And
part-
we
it's all
didn't
part-
actually. We
it's all
didn't
a part
come
of the one building.
to Spain for a while.
But it
so
runs
maybe
two
easier.
because I understand you want to only one process.
Stay there for.
Oh yes, I'll call you.
Oh, so Mod Whiskey runs
To at least give me some
inside
places where I can
the
eat and
module which is loaded in.
What?
And
See you around.
Want to go and see you around?
so the Apache query process,
tissue
it's got
for
all
my-
child worker processes. And Mod Whiskey in this case is actually within
all by
Apache
definition.
forking out a daemon process to run the Whiskey app, and the child worker process is actually just copying it. So I'm setting up all those connections.
I think we should have a contest real quick. What year was OpenShift first released?
Which one?
The first one.
The first one was released. The OpenShift one.
Okay, let's change. What year did OpenShift Online go GA?
This year?
No? Any other guesses?
3 years ago?
3 years ago? 2012?
When the Earth was formed.
3 years ago, good enough. What size do you wear?
No.
Large. Steve, you got any other trivia questions while we're waiting?
What?
Ask another question.
On the spot like that?
Yeah. What is the open source version of OpenShift called?
Origin.
What size do you wear? What size?
Excel, I think.
XL. I have XL. This is the shirt I'm wearing. If Steve asks more questions, I'll give more t-shirts
I'm
away.
trying to think of interesting questions as opposed to your questions. I'm not gonna ask this.
Oh, you got it there?
What country is Jorge from?
Spain!
What size? Ew, that's the only one I haven't seen.
Well,
L.
we'll do it.
I can do well.
How do you know
What?
where I'm from? Do I know you?
No. But I know you. Thank you.
Okay, so what is the national animal of Poland?
Buffalo.
What?
Buffalo.
No. It's a bird. There's a hint.
Eagle.
What type? Okay, great. What? But a little bit more specific. What's the color? You gotta get the color right.
Black eagle.
Black eagle.
Red eagle. What are you talking about? Who said white eagle?
She said black eagle.
Well, then he doesn't get a shirt. Who said white eagle? I heard someone say white eagle. White eagle gets the
What
shirt.
size do you want? Medium?
What is your national animal? And you eat both. That's nice.
We're the only country as far as I know that eats
Okay, I'm gonna go for another one in this area. And this is not a typing contest for the rest of you. You do it well. No.
Yeah.
Oh, here we go. No, they don't have one. Okay, this is a mythical one. What is the national animal of Greece?
Vodka is mythical. Olive. Phoenix. Wrong. No one gets a shirt. What's the national mammal of Finland? What? Wolf? Moose? No. National animal. The national mammal. So no, I'm excluding the birds. I'm giving those people who don't like birds a chance. God, you guys, no. Who would pick a reindeer as a national animal? Come and step all over us and think of people, when they think of countries, they think of something strong. What is the national animal of Finland? A bear, a brown bear. Yes. Brown bears are everywhere. Okay, I'll keep it in Europe just to try to make it easier for you. Although obviously this is not working.
Where is the largest Red Hat engineering office?
Grant! You're the good cop and I'm the bad cop. Okay, I'm going to find another.
Steve, can I start?
I'm handing out t-shirts. No, why are you looking at me?
Because you are talking.
Grant's the one who keeps up. Ask him if he's done.
Okay.
National animal of Netherlands.
Unicorn.
Who said unicorn? That was a t-shirt. Go ahead. Anyone? There's nobody from the Netherlands? What? Yes! Lion!
What size? Alright.
Can we do that during the break? I'm not during my time.
People want t-shirts more than
I know. Yeah, I know.
What is the national animal
Steve.
of Romania?
Enough. Please.
Oh, we're starting?
Yeah.
Oh, I didn't see Grant come back here. Sorry. You got a heads up for the next question, though.
Okay. So for the next 40 minutes, 30 minutes, if I'm fast and you'll have time for questions, I'm going to talk to you about building your own origin. Origin, as you just said, is the upstream for OpenShift. Who I am? I'm Jorge Morales. As somebody said, I'm from Spain. I don't know how he knows, but I'm from Spain. You can guess it. Once I start talking, you can guess it. Until I start talking, probably it's not, because I'm tall. Probably I'm from any other country. This is my picture, so if you reuse my presentation, you have to modify it at least. Okay. Where do I work? I work at Red Hat. Of course, this is a Red Hat conference, so we are here, most of us, we are here at Red Hat. And what do I do for a living? I work as a developer advocate for OpenShift. That's why we are here talking the whole day about OpenShift, and I just invite you to join all the other sessions around OpenShift. What do I do mainly for a living? I do demos, workshops, talks, conferences, blogs, and travel. We travel a lot, every day on the road. But the good thing about traveling is that we drink beer, we meet people, nice people, and we are in countries with nice weather. Not this one, but with nice weather. Okay, let's go to the talk. What we wanted was an OpenShift in a VM for doing my talks, conferences, workshops, whatever. Okay. So I started doing some research on what was available when I joined the team, because I'm very new to the team. I'm only here for 6 months, and I started doing some research of what was available at that time. There was a whole lot of options, so I went through all of these options. The first place to look, of course, it was the official Origin repository. They have a vagrant file to allow you to create a VM. It was community version. It was maintained, obviously, continuously. They are working on it, so it's always up to date. But for me, it had some cons. So it only set up the VM. So there was a lot of manual steps to do in order to have a full OpenShift Origin VM working, or process working. It was not easy to update. There was a lot of scripts that they are hidden in a hack directory, and there is a lot of stuff. That wasn't simple. You need some code redirection to access to your application, and there wasn't too much documentation. Why? Because engineers don't like to document. So they know how to work. Why? Because they chat in the IRC, they know each other, they sit beside one and the other, they know how it works, but for external consumption, it wasn't easy. There is another VM or effort to create a VM that's also from Red Hat, which is the Container Development Kit. That is something that we are creating to allow developers to interact with OpenShift. As we are developer evangelists, we want the developers to work with OpenShift, so this seemed like the best approach or the best option for us. But one of the pros, is that it's a full image, it's ready to work, it's usually up to date, but on the con side is the enterprise version. So we couldn't use it. Why? Because the enterprise version is not meant to be used anywhere for free or give it away. It's just for customers who pay it. That's not really true, but that's more or less. It's not yet there, so they are working on creating this, so it didn't fit my needs. So I looked at the community version for the same. Why? Because as we are Red Hat, we develop everything upstream first, and then we create the enterprise version out of it to sell it commercially. So this Atomic Developer Bundle was the upstream version of the CDK. As a pro, it was the community version, of course. That means that it was more suitable to use. It was the full image, ready to work, up to date, maintained, documented, but it has some things that I didn't like it requires some background plugins to set up for DNS, for setting up the VM, and it's also a multi-purpose project. That means that is not only for OpenShift, but it's for a set of projects that we are creating in Red Hat, like Atomic Enterprise Platform, Newlecule, and something else. So I didn't think that it was tailored only for OpenShift, so we start digging more. There were more demo environments available out there, created by probably Red Hat consultants that whenever they go to customers, they have to create their own stuff. There was no pros from most of this. Why? Because it was the enterprise version. They were not maintained. Once the guy did it, every time new release come, they didn't maintain it, so it wasn't an option. And there was another thing that it looked really cool at the beginning, which is OpenShift in a container. That's developed by a Red Hat engineer, and it's community version. And it was really cool. Why? Because you run it as a single command. So you do oinc, and you do up or run, and then you have an OpenShift installation. But the con was that it wasn't using a VM. So that's something to test on your host. I don't want people to pollute their host. That's one of the main reasons. And also on Windows it didn't work, of course, because of that. It was written in Go. It wasn't easy to understand, so that wasn't an option for us. And then we have the Fabricate, which is another upstream project from Red Hat. But this one, it was really cool. It's really good VM for getting started with OpenShift. It's community version, and there is a lot of documentation, but then you have Fabricate on top, which is not what we wanted to show. So we wanted to show OpenShift, and Fabricate is adding a lot of stuff, cool stuff, to be honest, but that's not what I wanted to show. So none of this worked for me. Well, really, when I say me, I'm saying it didn't work for the team I work. And to be honest, it didn't work for just one guy, who is the guy that talks the most and always complains. And you just saw him talking, Steve.
The only way to get me to shut up.
Yeah. Yeah, but I'm promoting you, so if you want to follow him, he's very chatty on Twitter. But don't follow me, I only have 38 followers. Don't do it. I don't say anything interesting. That's why I promote my colleagues. What we wanted. So we wanted, after doing this research, I had with a pretty understanding of what I was looking for to create a VM for us. So I wanted to be based on the community version of OpenShift, because we are developer advocates. We want to promote the community version. I wanted to have the process that builds this VM, I wanted to be open source. So to be easily accessible for everyone. So if you want to just change and adapt to your needs, we are Red Hat. We want to be open source and allow you to modify whatever you have. I wanted to keep it up to date. So that means that with every release, we wanted to be able to have it to release one new version of this VM. It's not only the process that we are following to build this VM that is continually updated and keep up to date, but then out of this VM, we are creating a packaged VM that we ship or we promote in our OpenShift.org/VM site. So that's the official VM that we promote as a community version. We want it to be easy to understand so that anybody that looked at the code could understand it. So we didn't want to base it on Go or any other language that was really complex. We want it to be flexible in options, so whenever you create the VM, it could suit your needs. So if you want to do things like install a different branch of the code, you can do it easily. If you wanted to add additional capabilities to the VM, it was easy to do it. So we created, or at least we think we have created it in a flexible way that allows you to provide with more capabilities or just the capabilities that you want for the VM. It's packageable. That means that we create the box that we ship in OpenShift.org. We ship it with this process. We create it with this process so that we eat our own dog food. Okay? We wanted to have the ability to peek into features in progress. That means that we talk constantly with engineers that they are developing in Origin. But the only way to look at whatever they have done is to build the latest code on the Origin side, or even a branch they are working and they are trying to do a pull request or merge a pull request into. You need to build that and to create or install an OpenShift installation out of that. And that's really a hard process. So we wanted to just look at what they have done. So if we have any comment to make on the developer experience out of it, we could make it before it really gets into the product. We wanted to have the ability to pick, that's what I just said. We wanted to be able to build it whenever we wanted. So that means that it's just a matter of, I need to build a new version. You just run the build commands. It's wrapped with Vagrant, and you just have an updated version. Of course, if you are building OpenShift, it will need a big internet connection to pull down a lot of things out of the internet. So I don't recommend to do it here today, but that's you can build it anyway. That's why I will show you how it's been built, but I will use a video, and that's because the internet connection here sucks. And also it takes more time than it should. With a video I can slide fast forward. And we want it to be usable on different hosts. Why? Because most of the developers usually use Windows, maybe not in this room, but usually use Windows. So we wanted the VM to be usable in Windows, in Mac, or in Linux. So here I am presenting our own version of the Origins Vagrant VM that we're creating. It is as easy as doing a Vagrant app. Once you do Vagrant app and wait for a while, you'll get a full VM ready to work with OpenShift in it. There is no additional plugins required, so that means that apart from Vagrant, and of course the virtualization technology that you are using, whether it's VirtualBox or Libvirt, you don't require anything else. There is no additional plugins required. You don't need anything for DNS setup. You don't need anything for configuring different technologies or whatever. Just Vagrant. There is no fancy port redirection. We are using the service zip.io, which is a hosted online service. So we use this service to be able to access the applications that you develop on OpenShift. That means that it's not suitable for working fully disconnected or not completely, so you will not be able to access the final application. You will be able to develop applications on top of OpenShift, but it works very easily and there is no configuration. So it's fully configured for you. You don't require to do anything, but and it's also fully maintained and supported by me and by the community, that I hope it will become your community. We have a lot of provisioning options. That means that if you want to customize things like the Origin repo or branch to use, let's say that there is an engineer, Michal Fokcik, and he's done something, and you see his pull request, you want to test it. So you just create the Vagrant image or reprovision the Vagrant image with that repo, and you test his pull request. You can set up the VM IP. So if usually we ship with one IP, but if it conflicts with whatever network you are in, you can change it and adapt to your needs. And then all the ship IO and all this stuff will get configure related to the IP you configure. It configures also the OpenShift domain for the applications. That means that you can provide whatever name, whatever domain you want for the applications, and it allows you to specify what additional capabilities you want to add to the image. We'll see what are we working on, what additional capabilities we're working on, but there is a lot of set of things, so you can have a base image, and then you can have a base image created with a lot of stuff in it that's additional to OpenShift itself. We have runtime options. Which runtime options we have? Memory and CPU. That's it. You don't need to specify anymore. That means that if you create a VM and you package it and you provide it to anybody, the VM will work just by itself. It will be a very small vagrant file, and they just need to tailor the memory and CPU to their needs. It works with libvirt and VirtualBox because we wanted to be able to run in different hosts for Windows, Linux, and Mac users. And it's scripted in Bash. That means that it should be easy for anybody to understand, to tweak, to change, modify, adapt, whatever they need. I have a middleware background, and that's also one reason because I chose Bash and not any other thing more complex like Perl, Python, Go, whatever other scripting language. There is the creation of the VM follows 4 simple steps, which is configure the OS layer, configure the Docker layer, configure the origin layer, and then provide with anything additional on top of that. On the OS, you can configure all the base packages that you want. We provide the minimum. You can, of course, tailor to your needs. And we try to make the image as small as possible, so things that are tunable in size or that can grow in time in size. As we learn, we try to limit them, like the journal size. So we provide with a very small journal size because a developer usually will not look at the journal. So the thing is that once you have a VM working, probably the journal starts growing and your VM starts behaving slower. On the Docker end, we just configure Docker and we start it. One thing that we do is because we are using as a local environment, we are using the loopback file system because it's the easier one to set up. We limit the size for this loopback file system for the containers, so it doesn't grow as much as your VM and it doesn't get to a point where you cannot use the VM anymore. Then on the origin end, it's as easy as go to the origin repo, whatever you have there, and check out, or update if you already have it with the latest that's in the repo. Build it, then configure origin, then start it, so you have the full VM with it started, and then add some services on top, like the OpenShift registry, the router, and some templates. So whatever is required to have a minimal installation ready to use for or by developers. And then we have an additional script that will grow within time, that it will provide with additional capabilities to this base installation. Things like the metrics. Maybe you don't need the metrics at all because you are a developer. So you can select whether you want to install it to have your VM with it or not. The logging capabilities. There is a centralized logging capabilities that's using the ELK stack. You may want to have it in your installation or not, because as you add things to the installation, the VM will get bigger, the installation will run slower. Some templates, so we have the enterprise version of the templates. If you want to use it for demoing in the enterprise, that's fine also. There is some work in progress to add some additional users with different capabilities, with different roles, so you can test things with different roles. To show persistent volume capabilities using the NFS, so we'll set up an NFS server in the VM, and then it also allows you to cache or to pull down all the images. So every time that you want to work, everything is already in your VM, and you don't have to wait for different images to pull down from the internet. And bonus, we have some scripts that we are using to show OpenShift that we also put in there. So if you want to, let's say, show or try with a Nexus installation ready to work in an OpenShift environment, there is a script that you just have to run it, and it will install a Nexus instance in your environment. And a lot of the demos and the stuff that we do, we'll put it in there so you can just try it. So now I have two videos. One shows how to create the VM from scratch. So I just pull down my GitHub repo and I do a big tab. I don't have to do anything else. And this will start following all the provisioning process. So it's creating, I'm using libvirt for this one, and it's creating, I'm just checking that I don't have anything running on that IP, and it's running all the scripts. So I will you'll see that it updates Fedora, it installs Docker, blah, blah, blah. This takes some time. Then we see that it's executing. So all these fancy numbers are for all the scripts that are run. Whenever they are run by Vagrant, has these numbers, and then you'll see the execution of each and then. So we are cloning origin, we are building origin, and then we are creating the service, and then we are creating the router, whatever, the base templates that are required. And after we are installing some additional capabilities, and after we install all the additional capabilities, the installation will be up and running. We'll have a origin up and running in minutes. I have a decent internet connection at home, so this for me takes something like 6 minutes to build from nothing to a full OpenShift installation, building from source code. And to be honest, the most time it takes is to install Docker and to build origin. Then this is the installation that you have. As you can see there, you have the IP that I'm accessing the VM is already preset by me, and I'm going to create an application, and I'm going to, and it's showing also what's the URL to access that application using the domain for the application that I provided at the setup time, which is the default one. So this is creating a PHP sample application with the sample repository. It's building it. You can see the logs, how it builds the application, and then you see that it's already been built, and then we can access the application. And this is here. This is where your applications will be exposed, and this is why you require an internet connection. But at the end, if you are using or building something in Origin, you will require an internet connection because you will be pulling down dependencies probably for your application. So that's something that we assume it was something required, but we prefer to use this way. And now, I don't know what's doing now. And now we see that we have, in this VM, it's doing it again. This is the application itself. And then what we see here is that it also has the metrics capability, so that's something additional, usually not installed by default. If you want to see the metrics because the application that you are developing, you want to have this kind of ability, you can just add it. And then you can just log in with the regular command line to the VM, and it will just work with the OC client, as some of you have seen in previous workshops this morning. Okay. And there is this other option. When you have already your VM created, but you just want to test some capabilities. You don't need to go again and create the VM again from scratch, because that will take a lot of time. So you just run the provisioning step with the VM. So this is another video that I have. So what I do is, I was looking at this pull request from Fabiano France for a new feature that was going to go into the product. So this feature, what it does, it's add an about box here that it will allow you to download the client from the web console. So I wanted to test it. How do I test it? I just reprovision the VM with the repo username of the whoever is doing the commit and the branch. So this is something that you'll get in the pull request. Whenever you are watching to a pull request, you'll get this information, and you just background provision instead of vagrant app because your box is already running. You just say, okay, let's reprovision this. It takes some time that I will skip. And so once you access the VM, you can see what he's done. Okay, this is whatever he's done. So this is a way of having the latest and greatest, or checking whatever you want to check of what the developers have done. So during this process, at the beginning, I told you what things we needed, what were the requirements that we needed for the VM. We wanted to be open source, so this is hosted on GitHub, so you can use it and access and tune it and modify it. We wanted it to be based on the community version, that's using the origin. We wanted to be maintained up to date. It's maintained up to date because we are using it to create our own VM, so that's why we are keeping it up to date. We have we have to provide this level of quality. It's easy to understand because it's written in Bash. It's flexible in provisioning option, although you don't have a lot amount of provisioning option, but you can do some provisioning. You can package it. So there is one way. Once you create this installation, you can just do a vagrant box package and create with the VM, one VM that you can reuse with everything that you have set. So it will just create, it start with the VM fully configured. That's what we do for the OpenShift or VM. You can look into features in progress, how I just show. And you can build it whatever you want, and you can use it in different hosts. So check it out, please. That's the link to the repo. Or use the package version. Don't worry, there is a link to the slide at the end where you can get all the presentation, links to the videos and everything. So use the package version if you want. That's our version in the OpenShift.org site, and read the usage docs. So for the VM that we provide in the origin site, we also provide with the lab something similar to what Grant has done during the morning, that can help you walk through all the usage of OpenShift. So creating an application, hooking one application, or linking one application with a database, deploying templates, what's templates, and all this stuff. So don't kill me if you don't like it. Just do some pull requests, submit issues, help us make it better. Or just don't use it, of course. Thank you for listening to me. And if you have questions, now is the time for them. And if you want this presentation, it's there. So this is the only link that you really care, because all the other links are in there. Thank you. Questions? Come on! There are no questions?
I have a question.
Okay, good.
How you do the libvirt provider? Because on the link there's only VirtualBox provider published.
We don't provide yet the packaged VM for libvirt. We are working on that. But if you are using the libvirt provider, or you want to use the libvirt provider, just clone the GitHub repo and Vagrant app, you will have it. As long as you have the libvirt configured for Vagrant, it will work. That's it.
I think we have an issue filed for that particularly, so hopefully soon.
Yeah, we have an issue to publish the VM with libvirt on the origin side.
Okay, so
It
as
works.
the person who makes the VM, now that Jorge has made his script, it's basically all I do to make that VM, honestly, is I run his script, I do a little bit of like cleaning the file system with like writing it all to blank so that Vagrant can compress it when it packages it. And I make a new Vagrant file, and that's it.
Yeah.
So there's
And
nothing-
there is instructions on the README file.
Yeah.
So if you go to the repo, there is instruction on how to create your own package version of running Liquid. Yes.
What's your maintenance policy against OpenShift? So probably when I will use your master, I always get something relatively new,
Yeah.
right? And you will continuously go to the next or the master of OpenShift.
Yeah.
But if I wanted something more stable, like OpenShift 3.2 or something like that, do you have branch or?
So this is Origin. This is not Enterprise. So 3.2 is the version for the Enterprise, but it relates to some version of Origin. The thing is that what we are doing is, because we are maintaining it, we are keeping it up to date to the newest releases. So probably within time, if you want to use like last year's Origin, you'll have to go back in commits for last year's
So
version.
you don't have branches or anything?
No, we have releases. We do releases for Origin. So you
Yes.
have regular release. If you navigate to GitHub, there is a releases tab. If you click, you will see like 30 releases or something.
So
those correspond to tags. So basically, if I go, when I'm building the all-in-one VM, based on Origin, I go into his script, and in his script, you can set an environment variable for what tag you can set both the repo and you can set the tag
branch.
or branch.
Okay, so I can find out.
Yeah. So what we'll be doing, that's something that it's good that we have this session because we'll get some ideas. Right now, there is only one master branch, but what we will be doing is every release that we publish on the Origin side, we will tag it so you can go back to that official version and use the 1.1.1 release of Origin. Right now, if you just clone the Origin side, you can run master, or you can just specify, as I did when I did for this branch, you can say Origin branch master or Origin branch version 1.1.1, and you'll have the 1.1.1 version. The only thing is that it will not get it from the package version, it will build it for you out of that branch.
But if you're using Ansible installation, there is
No, we are not using Ansible installation.
there is RPMs for OpenShift Origin. In OpenShift repo is an Ansible install repo. There is an Ansible installation for OpenShift.
As far as I know, that's only for Fedora 23.
No,
Right?
it's for as well.
For?
It's for CentOS as well.
Okay, then.
But, so here's the deal. Remember one of his points was, we as the evangelists wanted to test features when they were going in. Your RPM solution doesn't work for us.
No,
Because we-
it's a Red Hat RPM.
But that
Yeah.
still doesn't matter, because I can't go and then say, Mikhail has done he's testing a new feature. I want to actually, I don't even want tip. I want Mikhail's branch where he's checking in all sorts of stuff that might be broken. This script is generic enough. It builds from source, right? So we don't want the RPMs because we want to build from source. So we either build from in my case, when I build the all-in-one VM, I build from a tagged version that was released, like v1.1.1. And then I can link that to clients. But when I'm testing Mikhail's stuff, I want to build from his source tree to build a vagrant image. So the RPM, we don't use RPMs or anything packaged.
Yeah.
We don't use Ansible, none of that stuff.
So this is something that we created for us because we had a need. That's the whole presentation was our need. Okay, and probably it's not the best way. We are not engineers. We are not doing the proper approach. But we had a solution that worked for us. If it works for you, which I just explained, then fine, use it. If it doesn't work, use whatever you want.
If you do want notes on Ansible, we have a separate set of links
Yes.
for staging up a cluster of machines, but that's a different repo that you,
Okay.
yeah, it's available.
Yeah. And the point of this also is not to set up a cluster. The
No,
point of
it's
this
an
is
all
you
in
have
one.
one VM that runs everything you want, that you can easily just do stuff with. You don't get into all that DNS stuff. It's just one VM running, and it acts like an entire server.
More questions? Then you are relieved from me. Thank you.
Yeah.
Well, that is my charger.
Sorry?
You get my charger. I almost forgot it. I guess Steve McAdams said I can use that
What's up? You think so? I think it's that. When you get engineers and you start doing this kind of stuff that we do, well, you can do it better.
Yeah, sure. But then you will say, like, with the problem, what is better and what is good and what is correct. Hey, go!
I think we're gonna go eat somewhere.
Who's up next in here?
No, we have to go out.
Someone else.
But not now. Not now. So we have 1 hour, something like that. Now we start making well, we made a break.
Good, good, okay.
Because we move as a team, we made a break.
Yeah.
But this is important today?
Počkej, jsem myslel, že to tak kontinuálně.
Ale jestli toho nepřijde, tak OK, jo. Neříkaj tady to, jak to dělat. To je jediná
When you say CI/CD, yeah, I'm following your stuff as well. That's good, that's good.
Eric, let's meet at the booth. Okay.
Alebo môžeš proste povedať iba tak, že čo by si chceli vidieť.
A co když to nevím?
Tak to budem sedieť.
To budeš ty, jo?
Ako ja tu plánujem sedieť tak do druhej.
A tá Katarka nechodá.
That's basically what I use.
No, já jsem až odpoledne prostě právě.
Vagrant environment locally, so I can locally pull CI tests before I even push. Right? Yeah. Vagrant here, and then when I want to actually deploy, I'll use this Ansible repo. I'll set up a larger cluster, and that'll be my CI environment. Or the next stage.
You need an account?
No, this is the Wi-Fi.
Yeah, of course.
Yeah.
Go back. The repository is not running yet, right?
Okay.
I do too for my...
This is the Ansible installer. Just set up your own environment in Amazon or Google Compute Engine or on bare metal. If you have a cluster of machines that you own, you can have something called an inventory file that just has a list of IP addresses. And as long as you have a valid SSH key to access, it'll go log into all the IPs, use Ansible to provision a cluster of maybe 10 machines. So I ran a command.
Is there any way for the local environment to communicate, like pushing all the changes to OpenShift Ansible? Are you planning something?
If the best way to do that, once you have, if you've already built an image, then you just do Docker push.
Okay.
Docker push. Yeah, and then hopefully you have an image stream that throws and it fires an event anytime a new image arrives, and the deployment config will listen to that event and then possibly do a deploy based on what's in the deployment config. So for CI or staging, I always auto-deploy. For production, I maybe wait until they press the button and manually deploy for production. But whenever I have a safe time, right?
And for building the image, you have to do it locally, like commands?
Well, we already have. Oh yeah. Well, I'd use OpenShift to build it locally, so I could use OCSync into the environment, or I could actually. There's a variety of ways to build locally. Yeah, maybe OCSync. If I was using a hosted environment, I would just do a git push to GitHub. GitHub would listen for that hook. That would do a build in the cloud, and it should produce the same image.
Okay.
Right? It should, right?
Theoretically.
Yeah. But on the other hand, I could have a base builder image on my laptop with CentOS, and then maybe what they build in staging is on RHEL, right? Maybe they don't want to pay too many RHEL licenses. I get CentOS here, RHEL in the cloud, right? I still can build Docker images. I can push and pull Docker images based on CentOS, but when they go to production, it's RHEL, right? So nice to have different ways of producing the images and allowing people to enforce a standard base for compliance and consistency across your environment.
Thanks.
Yeah, you bet. Yeah.
It's not going to be really about presentation, but about organization. It's going to be really active. Don't skip any lecture or something like that. Yeah, this one isn't it? Yeah, thank you. It's just, I was looking for it. I could read it.
Yeah.
Yeah.
Should we prepare something before, or
No.
can we come and just improvise?
Yeah.
Yeah, just improvise. Yeah, and it has to be good because I need to know to lock my speak.
Yeah.
Because
When I return,
it will be 2 p.m. so it's just time to learn something.
great starter.
Energetyky podobný s tím. Je to no, vstupuju, takový meeting. Co si